Hello and welcome. Today's webinar is Assessing Cool Corridor Heat Resilience Strategies for Human-Scale Transportation. My name is Lacey Friedley. I am the Communications Coordinator at Portland State University's Transportation Research and Education Center. TREC leads the National Institute for Transportation and Communities, a university transportation center funded by the U.S. Department of Transportation. NITC consortium members, in addition to PSU, are the University of Utah, University of Oregon, University of Arizona, University of Texas at Arlington, and the Oregon Institute of Technology. NITC's research priority is improving mobility of people and goods to build strong communities. Our presenters today are Lad Keith and Kristina Currans of the University of Arizona. And just because she's in the picture, the third researcher on this project was Nicole Eros-Alardo, also of UA. Lad Keith is an interdisciplinary researcher working at the intersection of urban planning and climate change to create more sustainable and resilient cities. He has over a decade of experience working with diverse stakeholders to solve complex urban challenges in cities across the US. His current research explores urban heat governance and how cities can increase heat resilience through the mitigation and management of heat. Kristina Currans is an associate professor in urban planning in the College of Architecture, Planning, and Landscape Architecture at the University of Arizona. She studies the intersection between transportation and land use development. Although trained as a civil engineer, Dr. Currans' work bridges the transportation planning and engineering disciplines. Her current research and teaching emphasizes the rethinking and redeveloping new data and methods for applications in practice to help communities plan for the places they want. Before diving into the presentation, I'd like to let you know about a couple other upcoming NITC webinars. On April 17th, Marisa Zapata of Portland State University will share research on marginalized populations' access to transit. And on June 12th, Jordan Catcher and Elizabeth Soja of the NAR Initiative will present on building capacity in gateway communities through the NAR Academy. Today's presentation will be about 40 minutes long. Then we will have 15 minutes to answer your questions. During the presentation, please submit your questions via the Zoom Q&A. After the webinar, you will receive an email with a link to the video recording and presentation slides. If you are tracking professional development hours, this webinar is eligible for 1 hour of continuing education credit. A certificate of completion will be posted on the event page within 24 hours after the webinar ends. And with that, I will go ahead and turn it over to our presenters.
Great, thank you so much, Lacey. Let me pull up our slides. Yeah, so again, today I will be presenting with my colleague, Dr. Kristina Currans, assessing cool corridor heat resilience strategies for human-scale transportation. Again, myself and Kristina Currans are the presenters, and Nicole Eros-Alardo was another one of the co-PIs on this project. And our learning outcomes, so what we hope that everyone takes away from this presentation today is an understanding of planning for urban heat resilience, the ability to recognize and differentiate different heat mitigation and management strategies, and then also have a more complete understanding of the impacts of heat on transportation users and systems, and an ability to explain the challenges of evaluating local impacts of those strategies. And so kind of the focus of what our NITC funded project was. So to kick things off, of course, extreme heat is one of our major climate risks that we see increasing with climate change and urban heat island effect. And it impacts a wide swath of social systems and economic systems and environmental systems in our cities, all the way from public health to quality of life, the economy, energy and water use, infrastructure and urban systems, landscapes, agriculture, and then on the outskirts of our cities, of course, rural communities and our natural landscapes too. And so on the right-hand side, just some of those headlines from last year's record-breaking temperatures. It was the hottest year on record, of course, across the globe. But here in Arizona had lots of impacts. So record-breaking heat deaths, unfortunately. Lots of our saguaros were toppling due to the heat, and then also impacts on our agricultural systems. So to focus in on a couple of these in a little bit more depth, looking at the public health impacts of heat, heat is the #1 weather-related cause of death in the United States above all of the other climate hazards that we have. And even though it's the #1 weather-related cause of death, they're also widely acknowledged to be underreported. And so Arizona actually has a fairly sophisticated way of tracking those heat-related illnesses and deaths, but many other states are trying to catch up to that right now and don't accurately represent those numbers currently. Some of the latest research shows that there are approximately 12,000 deaths per year in the last decade, and those deaths could increase to 110,000 by the year 2100, so quite a large number. On the right-hand side, this is just a graph of those deaths in Phoenix, so the Phoenix metropolitan area, and you can see that there were 8 years of steady increases, and 2022 had a 25% increase over that 2021 number. And unfortunately, we just got the numbers in for last year, 2023, and those numbers yet again increased quite substantially. And so I think at this point, already 579 confirmed deaths. And again, that's just for Maricopa County, for the Phoenix metropolitan area, and quite a lot of deaths across Arizona and then across the United States as well. Also, substantial impacts of extreme heat. So nationally, heat already results in $100 billion of economic losses per year. That's anticipated to double by 2030 to 200 billion and go up to 500 billion by the year 2050. So huge economic strain on our nation. And that's related to labor safety and productivity, economic development efforts, tourism, and increased costs to healthcare, energy, water, and infrastructure, of course. And again, just focusing on Phoenix, because Phoenix is so well studied for those impacts of heat. Extreme heat in the Phoenix metropolitan area alone already causes an average annual economic loss of between 1.9 and 2.3 billion. And that's if no further action is taken. And so quite a substantial loss for some of these metropolitan areas alone too. And then focusing on transportation specifically, of course, transportation infrastructure is impacted by heat, so the functionality of infrastructure, and then lifespan and maintenance. And so, as many of the attendees will know, we have different standards across the United States for the thresholds that transportation infrastructure is built to, of course. So here in Arizona, it's built to a high heat standard, but in many other places, that standard has historically not been for extreme temperatures, right? And so that differential is what causes when we get those record-breaking heat waves, like what occurred with the Pacific Northwest heat dome. Some of those, the light rail or streetcar line melting, some of the roads buckling and things like that. And so as we see these extreme heat events increase in the future, we'll see some of those impacts to the infrastructure that was built for lower temperature thresholds increase as well. And not just the infrastructure, but we're also interested in the transportation mode choices and how heat impacts the types of transportation that people choose to use, and the health and safety, particularly of active transportation users. So those that are walking, bicycling, or using transit. And so those that are actually outside and exposed to the heat as well. So as has been mentioned, heat, of course, is an increasing climate risk. And what we're seeing with climate change is an increase in the density, duration, and frequency of extreme heat events, and then also a continual rise in average temperatures. And so what we're looking at is kind of the chronic increase of normal temperatures, but also if you see on the right-hand side of the graph, with that brighter red color, those chronic increases in average temperature put us into new thresholds for record-breaking hot temperature as well, kind of beyond what we've ever experienced in many places. This is due to natural weather variation. So even without the impact of human climate change, we would of course have hotter days and colder days, but climate change is supercharging those hotter days. And of course, the way that we build and plan cities and operate cities contributes to the urban heat island effect as well. And so we kind of have all three of those things working together to put us into new temperature thresholds. So the urban heat island effect, of course, as mentioned, is how we plan, design, and operate cities, makes them typically hotter than natural or rural areas. This is due to land use and cover change, but also the urban form, how we plan and design cities. So things like building height, density, and arrangement, the types of building materials and reflectivity that we use. And so that's why cool pavement is a pretty hot topic right now, looking at lightening up some of those colors so that they absorb less heat and they reflect more of the energy from the sun. also changes in vegetation and humidity. And then this is not as well known, but of course, waste heat emissions is a really large contributor to the urban heat island effect too. And so thinking of our transportation systems, traditionally powered cars by gasoline and diesel, all of those waste heat emissions from those engines running contribute quite a lot to the urban heat island effect. And then of course, air pollution traps a lot of that heat inside of our urban areas as well. And so, of course, just a point, heat is both a chronic and acute climate risk. And so just pointing out again, we have some of these record-breaking events like that Pacific Northwest heat wave in 2021 that really kind of went beyond the norms of what have ever been experienced before. So that's one type of event. So those record-breaking heat waves is certainly a concern. But we also experience here in the Southwest heat waves that, kind of increase the temperature beyond what they would normally be, but it's already hot here, right? And so here in the Southwest and in traditionally hot places, we have those chronically increasing temperatures that are also a big concern. And so our heat events in the summer now typically last for 3 or 4 events with no respite in between. And I'll just point out too that how we perceive these heat events is very different than how we perceive other climate hazards. And so again, that Pacific Northwest heat dome that occurred, estimates and research show that between 1,500 beyond maybe even 2,000 people perished during that event across the Pacific Northwest and Western Canada. And there was certainly media attention to it, but the response both on the policy and kind of the legislative side afterwards was much less pronounced than after something like Hurricane Katrina, where about the same number of folks died, right? And so just thinking through how we think of these heat wave events versus other kind of maybe more visually dramatic events like a hurricane, like again, that example of Hurricane Katrina kind of flavors our response to them. One reason of that is, of course, heat is very complex. And so Dr. Currans is going to talk a little bit about this and how this impacted our study. But heat is a very complex thing to understand and study in the built environment. And so when we say heat, we're really talking about a couple of different measures, right? In the right-hand side, many folks are familiar with urban heat island maps derived from satellites, so land surface temperature maps, basically what the satellite is estimating the different hotspots of an urban area or a city to be. But on the ground, what we experience is much different than those satellite estimations, right? And so you can see a weather station on top of the little building that's animated or illustrated here. And the ambient air temperature may be 90 degrees with 50% relative humidity. That 90-degree number might be what you see on your app on your phone or what the weather local weather station tells you the temperature is. What you actually feel, though, is not that 90 degrees ambient air temperature. What you experience as a human is going to depend on where you are in your built environment, right? And so if you're in an office that's cooled, you might experience that wet bulb globe temperature, which Dr. Currans will talk about a little bit later. At 74 degrees, that's going to be a very different thermal experience than you're walking out in the full sun, 87 degrees of wet bulb globe temperature. Or again, if you're under a shaded bus stop waiting for the bus with trees around you. And so again, that 90-degree number that you might see from the National Weather Service isn't really telling you what your thermal experience is going to be. And so that's an important part of our study that we'll explain a little bit more. And of course, another important point is that urban heat is incredibly inequitable. And so urban heat is not equally distributed across our urban areas. And this is true within the United States, but also communities across the globe. Lower income areas, minority neighborhoods, and marginalized communities are typically, and again, this carries globally, the hottest areas in cities, right? And so part of that is due to historic disinvestment or racist land use practices, but also just the basics of income, right? If you have more money, you can afford to have more landscaping, and that landscaping typically cools off your neighborhood more than if you're lower income and you don't have that money to invest in landscaping, or you may not own the place that you're living, and in which case you're subject to kind of the investment of the people who own the properties that you're renting from. And so just an example from Tucson, one of our wealthier neighborhoods in that Sam Hughes neighborhood, can kind of see, for us, this is a fairly vegetated neighborhood in Tucson, but some palm trees, some nice desert trees, and one of our lower income areas on the south side of Tucson, much less vegetation, much less shade, and that carries true again across many metropolitan areas. So it's not just the physical heat that people experience that's inequitable, but of course also our ability to respond to that heat. And so affordability and accessibility of healthcare, housing quality choice, energy for indoor cooling, and of course, transportation choices, right? And so the idea that you may be trapped in a certain transportation mode, or you may not have options for different choices. And so if you have access to a private automobile during a heat wave, your experience is going to be much different than if your only option is to walk or to bike somewhere, or if the bus stops in your neighborhood aren't fully shaded. And so kind of thinking through that transportation equity aspect as well. So with all that said, one thing that I research and write quite a lot about is the idea of heat governance. And so with heat as climate risk, we're really trying to call more attention to this idea that we govern heat, as mentioned before, very differently than we govern flood risk, wildfire risk, sea level rise, and drought in the United States. And so really looking at this idea that the actors, strategies, processes, and institutions that guide decision-making for both mitigating and managing heat as a hazard really need more attention. And that's why the project that we're going to talk about in a little bit more depth is really important to provide some of that critical information to decision makers so they understand how to act and how they can better help their communities essentially to become more heat resilient. My colleague, Sarah Miro, who is at Arizona State University, and I, a few years ago, wrote the American Planning Association's book on planning for urban heat resilience. And so the QR code links you directly to the book. It's funded by NOAA, so it's a free, accessible resource to everyone, so you don't have to pay for it. And in this book, we talk about urban heat resilience. And so again, that idea of proactively mitigating and managing urban heat across many different systems and sectors that it affects. And I'll talk specifically about some of those heat resilience mitigation strategies and heat management strategies on the next two slides. So the idea with heat mitigation are those strategies that reduce the built environment's contribution to urban heat. So really looking at how to reduce that urban heat island effect. So traditionally, the purview of urban planning, landscape architecture, civil engineering. So kind of more of the built environment professions. Heat management is the other bucket of strategies that communities are exploring quite often. And those are the strategies that prepare and respond to chronic and acute heat risk. So things like public health, emergency management systems, things like the National Weather Service doing alerts, all of that. And so I'll give a couple of examples of both of these on the next two slides. So some commonly used heat mitigation strategies, and again, these are coming from the book, but the book was informed by numerous kind of plan analyses and surveys that we did of planners across the United States and interviews. But looking at changing land use development patterns, looking at land conservation outside of cities to preserve those areas that provide a cooling effect, and of course, those transportation systems, which can unfortunately sometimes be a very large contributor to, again, to that urban heat island effect. Looking more at the site-specific scale for urban design strategies, so things like including shade structures, the use of cool materials within our individual sites, and then of course urban greening. So one of the most popular strategies is things like urban forestry, increasing parks or green infrastructure in different places to again make those hotspots less inequitable than they currently are. And then anything we can do to reduce waste heat, so any energy efficiency gains that we make through building projects, so energy efficiency of buildings and vehicles certainly can reduce the urban heat island effect too. And so electric vehicles certainly don't solve all the problems, right? And I know that they come with their own set of issues, but they do contribute less to the urban heat island than traditionally gasoline-powered vehicles. So, and then of course, reducing automobile vehicles altogether is ultimately going to reduce that urban heat island effect as well. On the heat management strategy side, cooling centers is probably the number one strategy that a lot of cities are currently looking at. So the idea that we provide, indoor cooled respite places for folks that don't have access to thermally safe environments during the day. Of course, cooling centers, I'll say, is a band-aid for the fact that we don't have safe housing or safe workplaces for everyone in the United States. But I think a lot of folks recognize that that's a really difficult problem to solve. So kind of standing up those cooling centers while we also try to solve the affordable housing crisis and get folks safe housing is really important. Even if you do have a house, though, oftentimes, again, if you're lower income, it might not be weatherized properly. You might not be able to afford your energy. And so looking at how we can increase the equity for those types of things to make those living spaces and indoor spaces more thermally safe. Things like early warning systems in partnership with the National Weather Service and cities so that they have coordinated responses when those heat waves do occur. And then, of course, from the public health sector, things like heat education and awareness campaigns. So that when those early warnings happen, citizens can take action and kind of know, and residents know what they're supposed to do on their own, right? Occupational safety guidance and regulations is a big topic right now. So OSHA is currently going through the process of including heat as one of their mandated work safety regulations. That's going to take a couple of years, though. And so we've seen some movement from different cities and states to act on their own, essentially, to make sure that heat is considered. And I would say for the transportation sector, of course, there's a lot of transportation construction workers, those traffic safety folks. So this is really critical for those folks who work outdoors in the transportation area too. And then, of course, energy grid resilience, both again with the idea that we make energy accessible and affordable to everyone, but also that we don't get into situations where we have a hurricane that hits, the power grid goes down, and suddenly everyone's exposed to the heat that follows the hurricane, right? And so there's been a couple of tragic examples, actually, of the last couple of hurricanes that have come through the Gulf Coast of America, where more people have died from the heat after the electric grid was knocked down than the hurricane flood and wind itself during. And so kind of underreported, but another thing that we have to think about. So I'll wrap up by saying this QR code leads to the University of Arizona's Extreme Heat Network, and we have a number of different resources and information if you're interested in kind of learning more or seeing what the nation is doing. So I'll just go through these really quickly. The US NIHIS is what it's called. The National Integrated Heat Health Information System is one. So kind of the interagency effort to address heat as a country. We also have a link to the EPA Heat Island Reduction Program, so one of the longest standing kind of resources for cities to plan better to cool themselves off. Of course, the 5th National Climate Assessment tells you kind of your projections and your current climate impacts depending on where you are in the United States. And then the Global Heat Health Information Network, which has a lot of really good heat health related resources and examples for cities to look at and kind of learn from as well. And with that, I will turn it over to Dr. Currans and let her share her screen for the slides.
Thanks, Lad. And hi, everybody. Sharing my slides. And just to brag a little bit about my colleague, Lad, his APA report that he mentioned won a state, Arizona APA award. It's a really fantastic report and really great whether you teach or you're in practice. It's worth a download. I'm going to be talking about the second half of our presentation, which is focused specifically on the NITC project that this presentation is based on. We wanted to make sure that we gave a broad primer about heat strategies, and so LAD was able to show us a wide variety of resources and information, so hopefully we're situated in the context appropriately. I also want to bring back Nicole Rosalardo, who was our colleague on this project. She is now an assistant professor at Willamette University in their public health program and epidemiology, and is a wealth of knowledge for those local in Oregon related to heat and heat-related resilience strategies. And I also want to recognize our students, Asha Vila, Lauren Heath, Ethan Whistler, Andrew Berkelbach, and Brendan Little, all of whom supported different elements and data collection processes for this project. So it was quite a strong team that collected a lot of data. In this project, what our goal was to think about specifically cool corridors and their impacts on human comfort. By human comfort, we mean how people who are pedestrians, cyclists, people waiting at transit are experiencing and feeling the heat along different corridor strategies. The primary goal of this study was really to focus on cooling pavements, which are treatments applied to the roadway network with the hope of reflecting or preventing heat from being absorbed into the asphalt. The photo on the right is the pilot treatment plus TI that was applied on a corridor in Tucson, which is the corridor that we studied. But there are many other examples of cool corridor strategies, including decreasing asphalt, increasing vegetation, trees, and other types of shade, which we've tried to control for. In our study was really inspired by the city of Tucson's interest in piloting some new plus TI pavement rejuvenator treatments and trying to determine whether the costs of these treatments reaped benefits for our community. In many of these treatments, there are lots of lab measurements and tests, but these are very controlled circumstances. And because they act somewhat like sunscreen, where they often are reflecting heat and radiation from the sun, we were concerned that actually these treatments might impact the experiences of people at a pedestrian scale along the roadway. So our focus of this evaluation was on pedestrian scale human comfort before and after the application of our first pilot treatment. By and large, a lot of these treatments are tested for pavement longevity. So thinking about ways to prevent the aging and the cracking that happens on our asphalt. So questioning, we have less of an understanding of whether when these treatments are applied in mass in an area, whether they might reduce urban heat island effect. That's really a question that we continue to have related to this specific treatment, but also the suite of treatments that other cities are testing and applying. So the way that we set up our study was a before-after case control, quasi-experimental design in the real natural environment to evaluate the impacts of cool pavement, specifically on pedestrian scale human comfort. We took a variety of measurements, but the three primary measurements that we were focusing on was ambient air temperature. This is typically the temperature that thermometers give us that we see reported in the news. We also measured wet bulb globe temperature, which is an index that includes or captures humidity, wind, and solar radiant heat. This is much more close. This is much closer to what humans, the human comfort or feel that people are experiencing. And then we also measured surface temperature. So at every hour, we went through and collected both the surface temperature of the roadway itself, as well as the sidewalks and the surrounding environment. The challenge of this study was that when we're not in a lab environment, it's very hard to control for microclimates and all the little variations in, people's front yard, the plants that people are planting, the walls that people have installed, and small features of even the right-of-way, including the location and materials that sidewalks are made of, for example. So we used some GIS mapping to identify specific road networks that were very similar in the environment to the candidate site for the treatment that the city wanted to pilot. We, from that analysis, identified three specific corridors, our treatment corridors, and our control sites. And then we measured just before the application, so in October 2021 to April 2022. And those dates and time periods were selected because of the similarities in the arc of the sun path, the temperature or anticipated temperatures, and a variety of other metrics related to what we know to be our average wind, and so on. We worked with the city because we were in the roadway. We worked with the city to also collect permits to access the site, which allowed us to help us control some of the traffic that was around those locations during the weekends. In all cases, it was weekend traffic, so it I don't believe was ever very congested by the time we were collecting data. In terms of our summary of findings, we do have a report that's out there, so you could read the more specific details about how we were trying to control for these different things. We focused really on the before and after measurements of treatment only. And we, in these regression analysis, controlled for the temporal autocorrelation. So if we're collecting measurements at every 10 seconds for an entire morning, 10 a.m. to 3 p.m., we wanted to make sure we're controlling for the temporal autocorrelation that occurs naturally by those observations. And we focused really on the centerline analysis because we decided that if we were going to see a major impact on what pedestrians might experience or feel, we would absolutely be seeing it at the center line. It might be more challenging to measure that at a sidewalk. So thinking about the outcome variables, the ambient temperature, and then the wet bulb globe temperature, which is much more closely aligned with human comfort, what people feel. We found significant relationships between the impact of shade on the centerline asphalt, with only slight reductions in the ambient and the wet bulb globe temperature. So these down here are degrees Fahrenheit. We also found slight reductions in ambient and wet bulb globe temperature related to increases in wind. It's worth noting that wind never got higher than I think 5 miles an hour. So it was a pretty low wind day in both of those days that we observed. But once we control for those, we control for location, we control for the timing of the observations, we really only see a significant and what I would consider somewhat negligible impact on ambient temperature, less than a degree after the installation. So great that it's negative, that what we're measuring is just slightly less, but I would consider this more negligible. In terms of wet bulb globe temperature, once we control for the autocorrelation, we're not seeing a significant difference before and after the installation, which I would consider maybe a positive outcome, that the reflective pavement that is reflecting that heat is not causing an increase in the heat that pedestrians are feeling, at least based on our observations and study design. This is just an example of with and without the lags and what that control for autocorrelation does to our estimates. We saw some fairly, well, what I would consider larger differences in the before and after across our different locations that we're comparing. But once we control for the temporal autocorrelation, those really diminish to being less significant and also a smaller effect size. When we published on Twitter that we were doing this in the before study, we got quite a few comments asking about whether this also increases potential UV exposure, either on the asphalt roadway or on the sidewalks. We didn't know, that wasn't part of our original study design, but we did collect 2 devices that allowed us to evaluate and measure UV index and UVB. So during our after study, we were able to measure basically what we were observing coming from the sky versus coming from the ground from those measurements. And we found that the reflective averages were less than 5% across our measurements, and often negligible if it's not, the high point of the day, 12 p.m. or so on. So relatively small. We also collected surface temperature information hourly. This was a more manual data collection. We used temperature guns that had to manually collect on the hour at each of these locations. And we just found that there were a lot of complications in comparing before and after of surface temperatures because the sample size was so much smaller. It was a manual data collection. We also found that the microclimates in our case controls were, even though we did a whole analysis to try and find sites that were very, very similar, one with the treatment, one without, we found that even so, there were such small, subtle things that impacted the microclimate that the case control comparisons were not as useful as we had hoped. So that's why we partly, at least, leaned on the before and afters, which provided a little bit more control in variations of the built environment. But I think this brings up, sort of one of our concluding thoughts, which is not very conclusive. Many of these tools that we're looking at for cool corridors and pavement treatments are really studied heavily in the lab. But when we translate them into the actual environment with all the variations in small plants, big plants, trees, shade, even watering schedules of neighboring areas can really have an impact on what we're able to measure and control for, which makes our ability to observe the actual impact of these treatments in the natural environment much harder to capture and understand. But this is a really key and important question that we need to continue to pursue because cities are spending a lot of money on these treatments. And if we're not seeing in the real world the impacts that we are estimating in the lab, something is off in the advice that we're providing. And we want to make sure that the treatments are actually helping us in some way. It's very possible that these treatments will still continue the surface longevity. In this case, it doesn't seem like they negatively impact the heat that pedestrian scale travelers are experiencing, but this is one of many different pavement treatments. So much more work is needed in collaboration with other types of scientists to help us understand the benefits or maybe the costs of some of these treatments. So I want to thank you, and Lad, if you can maybe pop back up and give a little shout out to all the other sponsors of your related centers.
Yeah, thank you, Christy. So of course, I'm thanking NITC for funding this specific project, but then also we have various research programs at the U of A. So the Southwest Integrated Corridor Field Laboratory funded by DOE, that's ongoing. Our CLIMAS, Climate Assessment for the Southwest, funded by NOAA. We're one of the BRACE grant recipients, Building Resilience Against Climate Effects by CDC. And we have a new P20 center funded by NIH. And so that one's called SCORCH, the Southwest Center for Climate Change and Health. And so, of course, like lots of different funders that all are contributing to this important work to protect our communities against the impacts of heat.
Thank you. And Lacey, Becca, I think we're ready to open for questions.
Great, thank you. So our first question is, do you have any examples of a place where cooling systems have installed successfully?
I think there's quite a few, and I think I would call Tucson's installation successful because it was installed. Lad, correct me if I'm wrong, there's a network of cities that are studying cool pavement treatments. Do you remember the name of that we could point them to?
Let me look it up really quickly. There's a couple of different networks for sure that are exploring it.
Thank you. While you're looking that up, I'll go ahead and ask the next question, which is regarding the cooling treatment for asphalt. Has there been a comparison of concrete versus asphalt on streets and human comfort?
Oh, that's a good question. I don't know that human comfort was really studied. ASU was also doing some evaluations. There are, I would say, two large categories of these treatments. Ours is much closer to a sunscreen. A separate type of treatment is more paint-like, where it's actually a color. It's a white type of paint that's installed. It also, I think when cars drive over it, it becomes sort of blackened by tires and dirt. So you may have seen something like that. That's more of a paint-like, and it's more the physical property that reflects some of those treatments.
Yeah, and to go back to the previous question, so the Global Cool Cities Alliance at one point was the main coordinator, and the city of Tucson was a partner through the Cool Roadways Partnership. I think the idea here, and I'm not sure how active if they are still, but the main idea is that for cool roofs at least, which is another really popular urban heat island mitigation technique, there are industry standards and there are kind of performance measures that have been widely agreed upon, but not the same for cool pavement. So that's why we're still a little bit in the early pilot phases of this. So
the next question is about how to do this work in states where climate change denial is still very present, and mentioning human-made climate change can be politically challenging. Any words of wisdom to share from Arizona?
Yeah, so I'll start off by saying it's not completely accepted here in Arizona either. And so, but I think heat is something that people are experiencing. And so it's hard to look at the weather and see the record-breaking temperatures. And at least from what I found, even folks that aren't interested in the climate change aspect do understand that heat is occurring, right? And so I think kind of focusing on the heat and the impacts and how to solve it. And not necessarily focusing on the climate change aspect in some places can be productive,
Yeah.
or even can be an avenue to eventually getting to the climate change point. So,
And similarly, Lad, in your part of the presentation, as you spoke to some of the economic impacts, that often is speaks to people differently than talking about what pedestrians feel or are experiencing. So thinking about the economic impacts of deaths and other health issues, the burden on our health network and so on, those are also very real problems.
This looks like I skipped a question about pavement markings. Are changes needed to ensure that the pavement markings like crosswalks are easily visible on cool pavement?
Certain types of cool pavement. So if it's the more paint type cool pavement, that does change the color of the pavement. This treatment, I was actually really surprised. I thought it would change the color of the pavement, but once it was installed and cured, it's near my house. I can't tell where the installation starts and ends. So it just sits there as more of a sunscreen.
Makes sense. How did the team control for the fact that the before date of October 2021 is a different season than the after date of April 22?
Yeah, so that took us a long time to figure out what made sense. So we compared the way in which the sun was going across the sky, so making sure it was at the same height. We looked at historic dates related to temperature and wind and humidity. And then we also originally, I believe, identified a range of dates and weekends to do this work, recognizing that when we didn't want to collect the data if a random storm came through last minute. And the temperatures were relatively consistent. So in our regression models, we also had airport temperature controls for the day and the hour of the observation as a control. I think there's also probably some more that we could maybe do to try and tease out some of the effects, include adding back our sidewalk observations and maybe controlling for the spatial relationship. But this again is a budding area of work for us, but also for others who are trying to take some of these estimates and bring them down to more of a local scale.
yeah, we had a lot of conversations both within the team and then outside with climatologists and stuff too. And so we have two main rainy periods in Arizona that influence the weather most. And so kind of our summer monsoon and then the winter rain. So we tried to avoid those as much as we could. But then even if we had gone at the same season the next year, there was a chance that there'd just be different weather conditions that would affect the study too. So it is hard to match even season to season and get the exact same conditions.
I will say though, that so much of the work that we have related to this is lab studies, simulations, and models. So real world observations that help us understand the impact of some of these investments is a huge area of work. So if there are any students out there looking for like a thesis project, this is an area of work that I think there's lots of questions that we have.
We've got a request for a clarification. Could you explain WBGT again?
Wet bulb globe temperature, which is the index or the metric that combines not just ambient temperature, but also wind and humidity, and I think solar radiation. It's collected with a device that has some additional measurements to it. So it's not just a thermometer. In order to combine it, it's a much closer measurement of what people experience and how they feel in the environment.
Yeah, commonly used by the military and then by athletic events too, to kind of protect athletes, protect the military folks in different conditions. So.
And I think also more frequently in occupational safety conditions, because the device that we use is called a Kestrel. And you can also get kestrels. You see them used in like construction sites where they're trying to capture or figure out when they need to stop working, those thresholds.
What was the albedo of the treatment? Like, what was the of the pavement treatment? What was the albedo?
Oh, I can't speak to that just now, but I could probably put a link in our presentation to the website of the treatment with all the other information.
Great, thanks. If the focus of the study is on pedestrian comfort and pedestrians are likely to be on the sidewalk, were measurements also made on the sidewalk adjacent to the treated street?
Yes, and we decided to use, at least initially, just our centerline observations because we thought that that would be where it would be experienced worse. So if we were going to measure a significant difference, we would definitely measure it at the center line. I think we have some interest in bringing in those sidewalk observations because we could also maybe start to tease out some of the microclimate variations that we had on either side of the street at each of their control and treatment locations as well. So it's another step, but our goal was to see if we can, in the worst location, tease out that effect. We did a little bit for ambient temperature, was not significant for wet bulb globe temperature.
The city of Temecula, California has water sprayers and misters along their sidewalk on hot days. Has that treatment been studied and is it effective?
Lad?
Yeah, so I believe there are some studies, like some academic studies that have studied them in specific locations. I think, unfortunately, like our study, they're also site specific. It's really hard to generalize those, and they can be effective if you're kind of like directly underneath them and the wind's not blowing. But then the moment the wind blows the kind of humidity away, the effectiveness decreases. So it's very dependent on the microclimate and kind of the microsite conditions too.
And Lad, locally here in Tucson, would that be attractive given our water constraints?
I would say that's probably why we don't see it so much here in the Southwest, is the water concerns and kind of the use of that as a strategy versus like just shade or indoor cooling. Yeah.
Next question, could you elaborate on economic impacts of extreme heat and maybe reference any studies you're aware of?
Yeah, so the main study, and I might have to put this in the chat after I answer this, but was done up in Phoenix. And so that's actually an area that needs a lot more research done. So economists have not looked at as much at the impacts of heat as they have the impacts of flooding or wildfire in communities. But I believe AE was one of the firms that partnered with the Nature Conservancy for kind of a landmark study in Phoenix that really delved into those economic impacts for just Phoenix alone. And I think the numbers were really shocking. And kind of that report's used by example in a lot of other cities that haven't been able to kind of replicate that study. And so again, I think the big points are thinking through like the labor and productivity impacts of heat, how that decreases it, the impacts on the workforce, but also cost of maintenance of infrastructure. And I think kind of looking at all of those together along with the increased cost of healthcare system. So
Next question could be related. We are finding that there is low interest in cooling centers from the community and higher interest in traditional AC access and increasing trees along roadways. So are you aware of any strategies in Arizona to make air conditioning more accessible or more affordable?
Absolutely. We actually the governor just passed our first extreme heat plan. And so was kind of after she declared an emergency declaration last year for the summer, all the state agencies started working on our first emergency response plan for extreme heat that was just passed a couple of weeks ago. We now have the nation's first state level chief heat officer, which will coordinate all of those activities. And one of those includes, of course, coordinating cooling centers, but also making sure that our light heat program is more effective at getting those funds for weatherization and air conditioning access. So I think, again, cooling centers are certainly a Band-Aid. And if we could just give everyone safe housing, like that would be my preference, but it's going to be really difficult to do that. So.
Got another question about the treatment itself. If the treatment is like a sunscreen, are there chemical runoff properties that could be an issue? And a related question, what about like reflective additives in the paving material itself?
Those are both really good questions. I don't know about the runoff, and I'm curious if they've done any of that. My background is not in the chemical application sort of sphere at all, but I can point towards the website. I do think that if there are other cities studying this, one of the claims that this specific treatment makes, which I have no idea how well it does, is it also neutralizes some specific types of greenhouse gas emissions as well. That's another thing that I don't know to what degree we can even measure that in the real world, outside of lab context. For one of the centers that LAD is our university PI on, there is somewhat of an interest of doing more extensive measurements at specifically treatments that have this specific plus TI type treatment, to try and capture some of those other things, but I don't know. So I'll add some more resources into the slides before we send them out, related to the specific treatment, and I'll look to see if they have any specific reports that might speak to those questions.
Yeah.
And I would just say that kind of the additional chemical concerns are also present with the more paint type products that are put on. So it's not just the plus TI, but kind of any kind of additional cool pavement. And so one of the reasons why the city was actually interested in this is that they already have to use the asphalt rejuvenator as part of their normal maintenance. And so that was actually one of the things they specifically said is this is already part of the process that we have to do. It's not like yet another additional chemical that we kind of put on top of it. So I think that that's something to kind of weigh into it as well.
It was part of their fog seal application, I believe.
Yeah.
Do any locations have a practice of locating services along transit routes and coordinating their schedules with transit to make sure that these places are accessible and well located to provide cooling locations?
Yeah, so for cooling centers or so I quasi answered that in the answers, and then I'll just point out too, I put the link to the report for the economic report in the answered part as well. So for cooling centers, absolutely. We're actually through the BRACE program in Tucson, providing our transit agency with information on the cooling center locations, and then kind of partnering with the public health department to see which of those routes are not currently served by a cooling center, and kind of prioritizing those for future cooling center recruitment and placement. And so I think we're doing that. I know Phoenix is looking at it in the same way, and Las Vegas is another example of a city that's kind of used their transit stops to kind of advertise the location of the cooling centers. I think we actually just completed a survey of cooling center users in Arizona, and it's not, the results aren't finalized yet, but I think since it's a large proportion of folks that are kind of affected by the digital divide, unhoused folks, people that don't have energy income for a phone or anything. One of the biggest requests by the majority of folks was for physical kind of handouts or like printed signage for cooling centers, because they can't access any of the websites that were developed. So I think that's a really important consideration.
Speaking of solar panels, are solar panels being used to provide shade while also generating electricity?
Yeah, absolutely. Here in Tucson, not just in our private parking lots do we have a lot of solar panels shading the parking lots and stuff, but kind of an innovative idea was that we actually have a lot of our school playgrounds for the public schools now have solar panels over them to kind of provide some cool spaces for the kids to play, but also provide some of that renewable energy as well.
Nice.
Yeah, there's also some research happening at our university and our ag departments looking at solar panels shading certain types of crops during some times of the year. So that's an interesting avenue as well.
That is. And I apologize that I thought that this last question was asking about a certificate for the webinar, but I think the person means, is there a certification course on this, like on urban heat maintenance? Do you know of any?
I don't know of any, but I would say, so again, the Global Heat Health Information Network does have master classes. They're not certified, but they do have different classes available on YouTube for free. And then heat.gov, which is the website for the National Integrated Heat Health Information System, also has various like webinars and educational resources available too. Again, not certified, but kind of more in depth on the different topics that we've covered today.
Oh, great. All right, well, thank you for a great presentation, Lad and Christy, and thanks everyone for joining us. Go ahead and conclude the webinar, and everyone have a wonderful afternoon.
Thank you.
Thank you so much.